Hello my friends. Well, in last video where we saw the actions that we should take to optimize the production or the potential of the reservoir in the well, the final part of the video we were talking about our task or our target, which is building the inflow performance relationship curve. That is because from there is when we start simulating the actions or options. So in this particular video now we're going to see in the software how we do it. By the way, the explanation that I'm going to do here is related to Schlumberger software, PipeSim, because it's the one I have been working in the companies where I have been, and so that's the one I can handle best. And the examples is because I did it when I was working on those companies. So right now we're going to talk about how to do it, how to get the results or the estimate results from those actions in the software. So the first thing we do is taking the information we saw in last video about swabbing tests, the DST and samples. We can build the inflow performance relationship curve, and like it says right here, we use Darcy if we are above bubble point pressure, and bubble if we went across it. So if we have damage, we sensitize what's the impact of the elimination. And in here we're talking about gas wells. I'm going in the future, I'm going to have a section about gas wells, how we do gas production wells, and what to do to control water production and to optimize gas production. Okay. All right. So the first thing we do is we build the reservoir part. This is what we get in this particular software. Because there are some providers of software, and most of them they have the same correlations and things. Okay, the difference among those softwares is that how friendly they are to for the user to download the information and to do the simulations. Okay, so the first thing we include all the sense that we see perspective that the team, you remember the team, they decide which zones to include. If the strategy of exploitation states that we should include them in the well, so we include them in the simulation. So, and then we decide if we're going to produce a commingle or if we're going to isolate them or whatever. The software allows you to include and to deactivate a sand at any time if you want to see how a single sand produces and how commingled sands produced. So the first thing we do is we include the reservoir, we include the pressure that we saw in the DST, we include the water cut, the GOR, whatever we saw in the samples, and the how we the swabbing test, how much the well produces different drawdowns. So right now we are interested in getting the inflow performance relationship. So we build the whole system. We include prospective sand. In the horizontal wells will depend on exploitation strategies. So we build the reservoir. We install a nodal analysis node right here because we want to see how much the reservoir is putting in the well. So we include it. We put the transportation curve or the transportation system, which includes the tubing string. We can put a lifting system, but we're not going to use it right now. Right now we're interested in how much the reservoir can put in the well, and then we sensitize the actions like frac, stimulation, whatever we are seeing as options to improve or to optimize the inflow. So we connected the nodal analysis node to the tubing, and we are ready to sensitize and simulate. So we all the simulations is done up to the THP, to the wellhead pressure, but in the future here we're going to see how we connect this to the gathering network. So we cannot see how to optimize fields. We can optimize the energy, we can optimize the gas of the field according to the compression of the gas compression available, and in case of energy and pumping system, we distribute optimum the energy, the electrical energy that we have available. So we are ready, we build the well, and we are ready to sensitize. If we have a PVT or if we don't have it, because it's an exploration well or an appraisal well, and we have some neighbor fields with the same reservoir, we can use the PVT just to define the correlations that best matches our case, and we can precise better the parameters to make sure that our simulations are going to be the best possible. Okay, so the software also allows you to get, according to the correlations, how precise our result matches with the specific correlation, and then we set those correlations to the software for the predictions. Okay, so like I say, if we have more than one sound, we need to match. The first thing we do in the software is match the real situation with the software outputs. Okay, the well could be vertical, and then we build everything that's vertical well. If we are going to change or see how the well can produce in horizontal configuration, we have an icon for that, and we change the vertical for horizontal, and then we put like I said, how much we want to navigate, 500 feet, 1,000, 1,500, whatever. So this is this could be the case. This is a real case for sure, and this is a case where that's just the vertical well from the swabbing test. That's what we get, and from here, after we match the well, we start sensitizing. So we can see, by the way, when we have an exploration well, we have the well and we can optimize the well, but we also design or visualize how the wells are going to be to develop the reserves, okay, for the whole field. Okay, so we have the how much the well increases if we drill a slanted well, if we frack that slanted well, and even if we go horizontal. Remember what we have said about horizontal wells. We need to know about the orientation of the sands and also the extension of the sands, because in an exploratory well we still don't know. We can think about it because geologists and geophysicists, they can, according to the seismic studies and interpretation, they can visualize things, but we are not sure yet, and we need to wait to drill more wells to make sure about it. Okay, So we already built everything, and we are, starting to simulate, and this is what we get. By the way, all those actions, like we said in the last video, those actions are discussed in the team, and we'll make sure that everybody is online for those actions, because geologists or geophysicists or reservoir engineers, they might have even operation guys and facility engineers, they have to be involved, because when we see a field, we see lifting methods, we see the gathering networks with the surface processes, like how we're going to treat the water, or we're going to separate the gas, and things like that. Okay, we need to know everything from the reservoir, drainage radio, to the well, to the surface, to the flow station. We visualize everything. Okay, next time we're gonna talk about the transportation curve. Now the lifting method, how we complete the well, and then after that we go to the flow station. Thank you very much for being there. Thank you.